something impossible just happened. On November the 12th, 2025, telescopes worldwide reported the same thing. Interstellar comet 3I Atlas didn't just pass the Sun, it changed shape, and every instrument watching it saw the shift. Stop. Think about that for a second. A visitor from another star system came close, should have behaved like every natural comet we know, and instead did something no comet should do. Mass loss that defied prediction. Radio signals that shouldn't exist. A nucleus that refused to break when physics said it must. And here's why that matters. If an object from deep space can shift form, shed mass far beyond prediction, and still hold together, then our models for how interstellar visitors behave are wrong. Every equation we've trusted, every simulation we've run, every assumption about what happens when frozen worlds meet stellar heat, all of it needs rewriting. That's not a typo. Scientists are concerned because 3I Atlas just demonstrated that interstellar objects follow different rules. Rules we don't understand. Rules that might mean the difference between natural phenomena and something else entirely. The data didn't make sense. When Harvard astrophysicist Avi Loeb analysed the perihelion data, he found something that made him double-check his calculations. The object had lost at least a sixth of its total mass in just days. Not weeks, not months, days. For a body estimated between 0.32 and 5.6 kilometers wide, that's not just unusual. It's mechanically impossible under standard comet physics. 68 kilometers per second. That's the speed Atlas recorded at perihelion, a velocity that should have torn any normal comet apart. But 3I Atlas held together, changed shape, yes. Lost mass, absolutely. But the core remained intact when every model said it should have shattered. The problem gets worse. South Africa's MeerKAT radio telescope array detected emissions from the comet's dust cloud. The first such detection from any interstellar visitor. Radio emissions from cosmic dust aren't unheard of, but the strength and pattern didn't match any known comet behaviour. The signal suggested particle interactions that our models couldn't predict. Nobody expected what happened next. When the comet passed perihelion on October 29, 2025, Hubble Space Telescope and ground observatories prepared to witness either a spectacular breakup or a gradual fade. Standard comet behaviour, predictable physics. Instead, imaging showed the coma structure reformatting, not collapsing, not dispersing, but reorganizing into density patterns that shouldn't exist. We need to be clear about something. This isn't about sensationalism. This is about data from the Minor Planet Center, NASA's Jet Propulsion Laboratory, the European Space Agency, and Johns Hopkins University, all converging on the same impossible conclusion. 3I Atlas behaved in ways that challenge our fundamental understanding of how matter behaves in space. 0.02 millimeters per second, squared. That's the non-gravitational acceleration measured near perihelion. Tiny, yes. But for an object this size, without visible jets or outgassing patterns to explain it, that acceleration shouldn't exist. It's like watching a boulder roll uphill with no one pushing it. The timeline makes this even stranger. July 1st, 2025. Discovery by the Atlas survey in Chile. Initial observations suggested a standard long-period comet. Nothing remarkable except its trajectory. July through September. Orbital calculations revealed an eccentricity of 6.8, marking it as definitively interstellar. Only the third such object ever confirmed after Oumuamua and Borisov. October 15th. As it approached the Sun, James Webb Space Telescope detected a CO2-rich coma. Normal for a comet, but the concentration ratios were off. The dust-to-gas ratio suggested processing by galactic cosmic rays over millions of years. October 29th. Perihelion at 1.356 AU from the Sun. This is when everything went wrong with our predictions. October 30-31. Mass loss accelerates beyond any model's prediction. Shape changes begin. November 1st-5th. Radio emissions detected. Nucleus remains intact despite extreme conditions. November 12th. Current observations confirm the object is still coherent, still accelerating oddly, still defying explanation as it heads back to interstellar space. The models didn't just fail, they failed catastrophically. Every computational simulation run before perihelion predicted one of two outcomes: complete fragmentation or standard sublimation patterns. 3i Atlas did neither. It transformed in a way that suggests either unknown internal structures or material properties we've never encountered. Think about what this means. We've observed thousands of comets. We understand their chemistry, their structure, their behavior under solar radiation. We can predict with remarkable accuracy how they'll brighten, when they'll fragment, how their tails will develop. This knowledge comes from centuries of observation and decades of space missions. 3i Atlas ignored all of it. The shapeshift evidence comes from multiple independent sources. Ground-based telescopes in Chile, Hawaii, and the Canary Islands all recorded the same morphological changes. Hubble's high-resolution imaging confirmed it. The European Space Agency's tracking stations verified the trajectory anomalies. This isn't observational error. This is consensus data showing impossible behavior. Here's what should have happened. As any comet approaches the Sun, solar radiation heats the surface. Frozen gases sublimate directly to vapor, creating jets that form the coma and tail. The closer it gets, the more violent this process becomes. For a small body like 3i Atlas travelling at extreme velocity, the thermal shock should have been catastrophic. The nucleus should have split. At 68 kilometers per second, hitting the inner solar system's radiation environment is like slamming into a wall of energy. The thermal gradients across the nucleus should have created expansion differentials that crack rock and ice apart. We've seen this happen to dozens of comets at much lower speeds. Instead, it reconfigured. The word reconfigured is carefully chosen here. Not broke apart and reformed, which would be strange enough, but changed its structural organization while maintaining cohesion. Imagine a building rearranging its floors while staying upright. That's the level of impossibility we're discussing. The mass loss tells another story. Losing a sixth of total mass, as Loeb calculated, requires either incredibly volatile materials or active processes we don't understand. But here's the problem. Volatile materials would have been detected spectroscopically long before perihelion. The James Webb observations showed CO2 and standard cometary molecules, nothing exotic enough to explain this rapid loss. So where did the mass go? The dust tail observed in September extended about 50 arcseconds, relatively small for a comet. After perihelion, that tail didn't grow proportionally to the reported mass loss. The material had to go somewhere, but our instruments couldn't track it all. Some scientists suggest the missing mass converted to particles too small to reflect light effectively, nanodust that our telescopes can't see. That shouldn't be possible either. Cometary mass loss follows predictable particle size distributions. We understand how solar wind and radiation pressure sort particles by size. Creating predominantly nanodust would require a completely different physical process, one we've never observed in our solar system. The radio emissions complicate everything. MeerKAT's detection wasn't just unusual, it was unprecedented for an interstellar object. The emissions suggested particle interactions in the coma that don't match known physics. Some researchers propose that dust processed by millions of years of cosmic ray exposure might behave differently when suddenly heated. But that's speculation trying to fill a gap in our knowledge. Every answer creates new questions. If cosmic ray processing changes material properties, why didn't we see similar behavior from Borisov, our previous interstellar comet? If the nucleus has some unknown structural reinforcement, how did it form in another star system? If the mass loss was caused by exotic chemistry, why didn't our spectrographs detect it? Scientists hate saying, "we don't know," but with 3i Atlas, those three words keep appearing in technical papers, in observatory reports, in private communications between researchers. The known unknowns are mounting faster than we can investigate them. The eccentricity tells us about origin. At 6,388, this object's path is so hyperbolic it couldn't possibly have originated in our solar system. It came from interstellar space, probably ejected from another star system millions of years ago. That journey through the void, exposed to cosmic rays and interstellar medium, might have fundamentally altered its properties. But altered how? Laboratory experiments on Earth can simulate cosmic ray exposure. We understand the chemistry involved, the structural changes that occur. Nothing in those experiments predicts the behavior we're seeing. 3 Atlas is showing us that our laboratory approximations of deep space might be missing something crucial. Let's talk about the intact nucleus. After everything, the extreme velocity, the massive mass loss, the structural reconfiguration, the core of 3i Atlas remains whole. Not just didn't completely fragment, but maintained enough structural integrity to continue exhibiting organised behaviour. This is like watching an ice sculpture survive a blowtorch. The current observations are even more puzzling. As of today, November 12th, 2025, 3i Atlas is about 2.15 AU from the Sun, heading outward. It's faint, magnitude 9.9, requiring a telescope to see, but it's still active, still showing that anomalous acceleration, still refusing to behave like our models predict. The distance measurements are precise, currently 372 kilometers from Earth. These aren't estimates, they're radar-confirmed positions tracked by multiple observatories. We know exactly where it is, how fast it's moving, where it's heading. What we don't know is why it's doing what it's doing. December 19th, 2025. Mark that date. That's when 3i Atlas makes its closest approach to Earth at 1.7984 AU, about 269 million kilometers. Still far, but close enough for our best instruments to gather crucial data. Every major telescope on Earth and in space will be watching. But here's what's keeping scientists up at night. If 3i Atlas maintains its current behaviour until December 19th, it will be the longest duration anomalous event ever recorded for an interstellar object. Oumuamua's strange acceleration was detected over weeks. 3i Atlas has been defying physics for months. The implications are staggering. We're not just looking at one weird comet, we're potentially looking at evidence that interstellar objects represent a completely different class of celestial bodies. Objects formed under conditions we've never observed. Objects carrying information about stellar systems we'll never visit. Objects that might force us to rewrite textbooks. Consider what we thought we knew. Comets are dirty snowballs, ice and rock held together by weak gravity and frozen gases. Heat them up, they fall apart or sublimate away. It's simple physics that we've verified thousands of times. 3i Atlas says we're wrong. Not wrong about our solar system's comets. Those still behave as expected. Wrong about assuming that what's true here is true everywhere. Wrong about the universality of our local physics. The non-gravitational acceleration is the key. That 0.02 mLm/s2 acceleration can't be explained by any visible outgassing. In Oumuamua's case, scientists proposed everything from hydrogen ice to solar sail. Effects. For 3i Atlas, those explanations don't work. The object is clearly a comet. We see the coma, the dust, the spectroscopic signatures. But it's accelerating like something else entirely. Some scientists won't say it publicly yet, but in private conversations, in hushed conference discussions, a word keeps appearing: artificial. Not as a conclusion, but as a possibility that can't be completely ruled out. When natural explanations fail, even conservative scientists have to consider alternatives. We need to be careful here. The scientific consensus is still that 3i Atlas is natural. The evidence for artificial origin is circumstantial at best. But the fact that serious researchers are even discussing it shows how far outside normal parameters this object has pushed us. The radio emissions might hold clues. If we can decode the patterns in those MeerKAT detections, understand what's causing them, we might solve part of the puzzle. But that requires observations we don't have yet. December 19th might give us those observations. The mass loss mechanism is critical. Understanding how 3i Atlas shed so much mass so quickly could reveal new physics. Maybe it's not traditional sublimation. Maybe it's something we've never seen because we've never watched an object pre-processed by millions of years in interstellar space undergo rapid heating. Stop for a moment and realize what we're witnessing. An object older than our sun, formed around another star, traveled through the void for eons, and is now teaching us that our understanding of physics might be provincial, limited, local. The experts are struggling. Avi Loeb, who's never shied away from controversial interpretations, calls the mass loss suggestive of unknown processes. Conservative astronomers who dismissed his Oumuamua hypothesis are now quietly admitting that 3i Atlas poses genuine challenges to our models. The European Space Agency updated their FAQ page 3 times this week. Each update adds more uncertainty, more currently unknown statements, more promises of future observations. They're being transparent about their confusion, which is both refreshing and unsettling. NASA's Jet Propulsion Laboratory keeps refining their orbital solutions. Every new observation slightly adjusts the trajectory, trying to account for that persistent acceleration. Their ephemerides, the mathematical predictions of where 3i Atlas should be, keep requiring correction. The object won't follow the path pure gravity dictates. We're running out of time to study it. As 3i Atlas recedes, it's fading. By early 2026, it will be too faint for most telescopes. By 2027, even our best instruments will lose it. This is our only chance to understand what happened. The shapeshift might be the biggest clue. If we can understand the mechanism that allowed 3i Atlas to reconfigure without fragmenting, we might discover new principles of material science, principles that could apply to asteroid mining, spacecraft, design, even planetary formation theories. Or we might discover something else entirely. 3 interstellar objects detected so far. 3 completely different behaviors. Oumuamua, elongated, tumbling, accelerating without visible outgassing. Borisov, typical comet behavior, almost boringly normal. 3i Atlas, shape-shifting, mass-shedding, radio-emitting anomaly. Pattern or coincidence? If there's no pattern, if each interstellar visitor is wildly different, that suggests a cosmos far more varied than we imagined. If there is a pattern we're not seeing yet, that might be even more profound. The December 19th observations will be crucial. Every major observatory has blocked out time. Hubble, James Webb, the Very Large Telescope, Keck, Subaru, they're all coordinating observations. Radio telescopes worldwide will be listening for emissions. This might be the most intensively studied single object in astronomical history. What are they looking for? Changes in acceleration, spectroscopic evolution, more radio emissions, any sign of structural change, any hint of what makes 3i Atlas different from every comet we've ever studied. The stakes couldn't be higher. If 3i Atlas is natural but operates by unknown physics, we need to revise our models before the next interstellar visitor arrives. If it's something else, and that's a massive if, we need to know before it's gone forever. Current distance to Sun, 2.15 AU and growing. Every day takes it farther away. Every hour reduces our observation window. The object that challenged everything we thought we knew is leaving, and we might never see anything like it again. Unless we do. Statistical models suggest we should detect an interstellar object every few years now that we know what to look for. The next one could arrive tomorrow, or in a decade. When it does, will we be ready? That depends on what we learn from 3i Atlas. The investigation phase is nearly over. Soon, we'll move from gathering data to interpreting it, from recording observations to understanding implications, from asking what to asking why, and what does this mean? But first, December 19th. Everything depends on those observations. If 3i Atlas continues its anomalous behavior, if new phenomena emerge, if the radio emissions intensify, any of these could crack the case wide open. The scientific community is holding its breath. Papers are being written with conclusions left blank, waiting for December data. Grant proposals are being drafted for new instruments designed to catch the next interstellar visitor. Graduate students are choosing dissertations that might be proven wrong or revolutionary within weeks. This is science at its most raw and uncertain. We're watching the unknown become known in real time, watching our models fail and scramble to build new ones, watching the universe reveal that it's stranger than we thought. The public deserves to know what's at stake. This isn't just about one weird comet. It's about recognizing that our cosmic neighborhood might be the exception, not the rule. That physics might be more local than universal. That objects from other stars carry information we're only beginning to know how to read. As we shift from investigation to meaning, remember this. Every piece of data from 3i Atlas is a word in a message we don't yet understand. A message written in the language of physics, sent across interstellar space, delivered to our doorstep by cosmic chance. Or maybe not by chance at all. We stand now at the threshold between knowing and understanding. Between facts and meaning. Between the investigation of what happened and the contemplation of what it implies for our place in the cosmos. The data tells us what. Now we search for why. And in that search, we begin to glimpse something profound about the nature of scientific discovery itself. Each answer we find reveals 10 new questions. Each certainty we grasp dissolves into deeper mystery. This isn't failure, it's the fundamental nature of exploring a universe far stranger than our ancestors dreamed. Think about what 3i Atlas represents in the grand narrative of human knowledge. For centuries we studied our local comets, building models that seemed universal. We understood sublimation rates, orbital mechanics, compositional signatures. We sent spacecraft to rendezvous with comets, landed on them, collected their dust. We thought we understood these ancient wanderers. Then came the visitors from beyond. First Oumuamua in 2017, that bizarre needle-shaped object that accelerated without visible cause. The scientific community fractured. Was it a hydrogen iceberg? A disk of frozen nitrogen? Something else entirely? Before we could resolve those questions, Borisov arrived in 2019, seemingly normal except for its interstellar origin, as if to say, see, some things are universal. And now 3i Atlas, shattering that fragile comfort. What these three messengers tell us is profound. The cosmos is not homogeneous. The conditions that shaped our solar system, that created the comets we know, might be cosmic exceptions. Each star system might be running its own unique experiment in physics and chemistry, producing objects we can barely comprehend. We are looking at postcards from alien laboratories. Not laboratories in the sense of intentional design, though we cannot rule that out entirely, but laboratories where nature itself experiments with different conditions, different materials, different processes. A star with twice our sun's mass would create different radiation environments. A system with more supernovae nearby would bathe forming objects in different cosmic rays. Even the density of the interstellar medium would affect how objects evolve over millions of years of travel. 3i Atlas spent longer in the void than our species has existed. Consider the timeline. This object was likely ejected from its home system millions, perhaps billions of years ago, while it drifted. Through the darkness between stars, Earth was still forming complex life. Dinosaurs rose and fell. Humans evolved, built civilizations, reached for the stars, all while this ancient traveller approached, carrying secrets we're only now beginning to read. In its transformed structure, we see time itself. The shape-shifting isn't just a curiosity. It's evidence of processes that require cosmic timescales to unfold. Whatever happened to 3i Atlas during its interstellar journey cannot be replicated in our laboratories or our solar system. It required the deep time and vast emptiness between stars. This is humbling on a scale we rarely contemplate. Our most advanced physics, our most sophisticated models, our deepest understanding, all of it is based on studying objects that have existed in our solar system's relatively gentle environment for a mere 4.6 billion years. 3i Atlas shows us that this is like studying oceanography by looking at a single tide pool. The universe is not just bigger than we imagine, it's more varied. Each interstellar object that visits us is a teacher, and the lesson is always the same. Abandon your assumptions. What you think is universal might be local. What you consider impossible might be routine elsewhere. The cosmos does not care about your models. But here's what makes this beautiful rather than terrifying. Science is not a fortress of facts to be defended. It's a method of learning, adapting, evolving our understanding. Every time an object like 3i Atlas breaks our models, it's not a failure. It's an invitation to grow, to expand, to become more cosmic in our thinking. We are witnessing science as it truly is, a living conversation with mystery. The December 19th observations aren't just about collecting data. They're about humanity reaching out to touch the infinite, to grasp something beyond our local experience. Every photon collected from 3i Atlas is a word in a dialogue between human curiosity and cosmic truth. And what if we can't explain it? What if, even after all our observations, 3i Atlas remains a mystery? That too would be a profound gift. It would remind us that the universe is under no obligation to be comprehensible to human minds. That mystery is not a problem to be solved, but a fundamental feature of existence. We live in a cosmos that surprises us. After centuries of science, after mapping the human genome and detecting gravitational waves, after landing on Mars and photographing black holes, the universe can still utterly confound us with a single visiting comet. This is not weakness. This is wonder. 3i Atlas carries a message about time and change. Its transformed shape speaks to processes we haven't witnessed because our observations span mere decades while the cosmos operates on scales of millions of years. We're like mayflies trying to understand seasons. We glimpse fragments, but miss the full cycle. Perhaps that's why it had to come from outside. Our solar system is too young, too stable, too familiar to teach us these lessons. We needed a visitor that had experienced conditions we can't imagine, that had been shaped by forces beyond our local physics. We needed proof that our island of knowledge sits in an ocean of mystery. The radio emissions might be the most poetic detail. Here is an object, ancient beyond measure, singing in radio waves as it swings past our sun. Not intentionally, there's no evidence of that, but as a consequence of its unique composition and history. It's as if the universe itself is broadcasting. There is more, there is always more. Every scientist studying 3I Atlas knows this moment is historic. Not because we've discovered aliens, we almost certainly haven't. Not because we've found new physics, though we might have, but because we're witnessing the expansion of human perspective in real time. We're watching our cosmic provincialism dissolve. The shapeshift is a perfect metaphor. Just as 3I Atlas transformed when it encountered our sun, we transform when we encounter 3I Atlas. Our rigid models become fluid. Our certainties become questions. Our local knowledge becomes cosmic curiosity. This is the gift of the unknown. In a universe where everything was predictable, where our models perfectly described all phenomena, there would be no growth, no wonder, no reason to keep looking up. 3I Atlas reminds us that surprise is still possible, that mystery still exists, that the cosmos still has lessons to teach. And perhaps the greatest lesson is about ourselves. When faced with the inexplicable, we don't retreat into denial or despair. We lean in. We build better instruments. We refine our questions. We admit our ignorance and transform it into investigation. This is humanity at its best. Curious, humble, relentless in the pursuit of understanding. The acceleration anomaly speaks to hidden forces, not mystical forces, but physical ones we haven't discovered yet. Just as dark matter and dark energy revealed themselves through gravitational effects we couldn't otherwise explain, 3I Atlas's strange acceleration might be pointing us toward new physics, or it might be showing us old physics in new conditions. Perhaps the known forces, gravity, electromagnetism, the nuclear forces, behave differently when objects are pre-processed by millions of years of interstellar exposure. Perhaps what we call laws are more like local customs, and 3 Atlas follows the customs of its birthplace. We are all children of specific stars. Earth's elements were forged in particular supernovae, organized by our specific sun, shaped by our unique history. 3I Atlas is the child of different stars, different explosions, different histories. In meeting it, we're meeting a cosmic sibling we never knew existed. The mass loss tells a story of transformation, not destruction, but change, not ending, but becoming. The matter that 3I Atlas shed near perihelion didn't disappear. It transformed into something our instruments struggle to detect. This is alchemy on a cosmic scale, matter shifting forms in ways we're only beginning to perceive. December 19th approaches like a deadline for wonder. After that closest approach, 3I Atlas begins its final fade from our view. By mid-2026, it will be beyond our reach, carrying its mysteries back into the void. We have weeks to gather what understanding we can. But understanding isn't the only goal. Sometimes the purpose of a mystery is to remain mysterious, to remind us that the universe is larger than our comprehension, to keep us humble, curious, and alive to wonder. The Atlas might leave us with more questions than answers, and that might be exactly what we need. We stand at a remarkable moment in history. For the first time, we have instruments sensitive enough to detect interstellar visitors. For the first time, we can study objects from other star systems. For the first time, we can compare our local physics with cosmic physics. This is a threshold as significant as Galileo's first telescopic observations. And like Galileo, we're discovering that reality is stranger than doctrine. Our textbooks, our models, our assumptions, all are being challenged by a chunk of ice and rock from another star. This isn't a crisis, it's a revolution. A quiet revolution happening in observatory logs and data files, but a revolution nonetheless. The future of astronomy will be divided into before and after 3 Atlas. Before, we assumed interstellar objects would behave predictably. After, we know they can surprise us. Before, we thought our physics was universal. After, we suspect it might be provincial. Before, we were confident. After, we are curious. And curiosity is more valuable than confidence. A confident science is a dead science. frozen in false certainty, a curious science is alive, growing, capable of transformation. 3i Atlas has given us the gift of curiosity renewed, of questions that make us beginners again. As December 19th approaches, we prepare not just our telescopes but our minds. We prepare to see something that might confirm our theories or shatter them completely. We prepare for answers that might be more mysterious than our questions. We prepare for the universe to teach us once again that it is stranger than we imagine. The countdown has begun, not just to a date on the calendar, but to a moment of potential revelation. Every day brings us closer to either understanding or deeper mystery. Both outcomes are victories for science, for curiosity, for the human drive to comprehend our place in the cosmos. 3i Atlas is leaving us, but its impact will remain, in transformed theories, in new questions, in the next generation of instruments designed to catch and study interstellar visitors, in the expansion of human perspective from provincial to cosmic. We are not the same species we were before July 1st, 2025. The discovery of 3i Atlas has subtly but profoundly changed us. We now know with certainty that objects from other stars visit our system. We know they can behave in ways that challenge our physics. We know the cosmos is more varied, more mysterious, more wonderful than we thought, and we know that we're just beginning to understand. The story of 3i Atlas is not ending. It's beginning. The real work starts after December 19th, when scientists worldwide will pore over the data, building new models, testing new hypotheses, preparing for the next visitor. Because there will be a next visitor. Statistics suggest one every few years now that we know how to look. Each one will teach us something new. Each one will expand our perspective. Each one will remind us that we live in a cosmos of infinite surprise. The fourth interstellar object might already be approaching. Somewhere in the outer solar system, too faint for our current instruments, another messenger might be falling toward the sun. What will it teach us? What assumptions will it shatter? What new mysteries will it reveal? We don't know. We can't know. And that's the beauty of it. In a universe where everything was known, where every object behaved predictably, where physics was complete and mystery was extinct, there would be no reason to look up, no reason to wonder, no reason to dream of what might be possible. 3i Atlas ensures that wonder survives. In its impossible shapeshift, in its inexplicable acceleration, in its radio song, it carries a message more important than any scientific data. The universe is not finished surprising us. Mystery is not defeated. Wonder is not extinct. The cosmos is calling us to grow, to expand our models, to question our assumptions, to embrace uncertainty as the price of living in a universe magnificent beyond our comprehension, to accept that we are not masters of cosmic truth but students in an infinite classroom, and what students we are. Armed with telescopes and equations, with curiosity and courage, we face the infinite dark and dare to ask, what are you? The universe responds not with answers, but with objects like 3i Atlas, riddles wrapped in ice and stone, accelerating through our neat theories, transforming before our astonished eyes. This is what it means to be human in the cosmos, to stand on one small world, around one ordinary star, in one galaxy among trillions, and still dare to reach for understanding, to know that we are provincial, limited, perhaps fundamentally unable to grasp the full truth, and to keep trying anyway. 3i Atlas is already 321 million kilometers away and receding. Every second takes it farther from our sun, our instruments, our questions. It carries with it secrets we may never unlock, physics we may never understand, messages we may never decode. And that's okay, because it also leaves us with something precious. It leaves us with renewed wonder, with questions that will drive the next generation of scientists, with proof that the universe is stranger than our strangest theories, with the certain knowledge that surprise is still possible. On December 19th, when 3i Atlas makes its closest approach to Earth, we won't just be observing a comet. We'll be witnessing a reminder that we live in a cosmos of infinite possibility, that our local knowledge is just the beginning, that every answer opens 10 new questions, that mystery is not the enemy of understanding but its essential companion. The instruments are ready, the scientists are waiting, the cosmos is about to teach us something new. Whether we understand what we see on December 19th or whether it deepens the mystery, we win. Because the goal was never complete understanding. It was the journey toward understanding, the reaching, the wondering, the transformation of ignorance into investigation. 3i Atlas has already succeeded in its mission. Not a mission assigned by anyone, but a mission inherent in its very existence. To remind us that we don't know everything. To prove that surprise is still possible. To demonstrate that the universe is larger, stranger, and more wonderful than our models can contain. As we watch it fade into the darkness between stars, we should thank it. Thank it for breaking our models, for challenging our assumptions, for refusing to behave as expected, for carrying into our ordered solar system a taste of cosmic chaos, for being impossible. Because in that impossibility lies everything that makes science beautiful. The not knowing, the reaching, the failing and trying again. The moment when data destroys doctrine and forces us to grow. The humility of facing infinity with finite minds and trying anyway. 3 Atlas changed shape, and in doing so, changed us. We are not the same. Our universe is not the same. Our future is not the same. All because one comet from another star refused to follow our rules, refused to fit our models, refused to be ordinary. In the end, that's the message. Not that we've discovered aliens, not that physics is broken, not that our models are wrong, but that the universe is under no obligation to meet our expectations. That mystery is eternal, that wonder survives, and when the next messenger arrives, whether next year or next decade, we'll be ready. Ready to be surprised, ready to be confused, ready to have our models broken and rebuilt, ready to grow, ready to expand our island of knowledge, even as we discover the ocean of mystery is vaster than we imagined. This is the legacy of 3i Atlas. Not the data it provided, though that's valuable. Not the theories it challenged, though that's important. But the reminder that we live in a cosmos that can still astonish us. That science is not a destination but a journey. That every answer is also a question. The countdown to December 19th continues, but in a sense we've already received the most important message. We've already learned the crucial lesson. We've already been transformed by this visitor from beyond. We've learnt that the universe is still teaching, and we, curious students, that we are still capable of learning, still capable of wonder, still capable of facing the infinite mystery with finite minds, and finding joy in the attempt to understand. 3 Atlas will soon be gone, travelling back to the void between stars, but it leaves us different than it found us, more humble, more curious, more aware of how much we don't know, more excited about what we might discover, more human in our cosmic context. This is what interstellar visitors do. They don't just bring us data about other star systems, they bring us perspective about ourselves. They show us that our local truth is not universal truth. They remind us that mystery is not a problem to be solved, but a gift to be treasured. As November becomes December, as 3D Atlas approaches and then recedes, we stand witness to something remarkable. Not just a comet behaving strangely, not just physics being challenged, but humanity encountering the truly alien, not in the sense of life, but in the sense of something formed under conditions we've never experienced, following rules we don't yet understand, carrying messages we're only beginning to read. The story of the 3i Atlas is the story of us, curious apes on a small planet, building telescopes to peer into infinity, discovering that every answer reveals new questions, and loving the journey more than any destination. This is who we are. This is what we do. This is why we look up. And on December 19th, 2025, when 3 Atlas passes closest to Earth, we'll look up again. Not because we'll understand everything we see, not because our questions will be answered, but because the act of looking, of wondering, of reaching for understanding, that's what makes us human in a cosmos of infinite mystery. The universe sent us a teacher disguised as a comet. The lesson isn't in the data we collect or the theories we build. The lesson is in how we respond to mystery, with curiosity rather than fear, with humility rather than arrogance, with wonder rather than indifference. 3i Atlas changed shape, yes, but more importantly it's changing us. From provincial to cosmic, from confident to curious, from thinking we understand comets to knowing we've barely begun to understand anything. And that's not a failure. That's the beginning of wisdom. The wisdom to know that the universe is larger than our theories, that mystery is more valuable than certainty, that every interstellar visitor is a gift, even, especially, when we can't explain what we're seeing. December 19th is coming. The telescopes are ready. The scientists are prepared. The data will flow. And whether it solves the mystery or deepens it, we'll celebrate. Because both outcomes mean the universe is still teaching, and we're still capable of learning. This is the gift of 3i Atlas. Not answers, but better questions. Not certainty, but wonder renewed. Not the end of mystery, but proof that mystery endures. Not the closing of a chapter, but the opening of a new volume in humanity's conversation with the cosmos. And when it finally fades from view, when our instruments can no longer track it, when 3i Atlas returns to the void between stars, we won't say goodbye. We'll say thank you. Thank you for the mystery. Thank you for the questions. Thank you for breaking our models and expanding our minds. Thank you for reminding us that we live in a universe stranger and more wonderful than we dared imagine. The profound nature of this gratitude cannot be overstated. We live in an age where cynicism often masquerades as wisdom, where mystery is seen as a problem rather than a gift, where the unknown is feared rather than celebrated. 3 Atlas reminds us of a deeper truth, that wonder is not childish but essential, that mystery is not ignorance but opportunity, that the unknown is not threatening but inviting. Consider what we've learned from just 3 interstellar visitors. Oumuamua taught us that objects can have shapes we never predicted, elongated, tumbling, more like a cosmic needle than the dirty snowballs we expected. It accelerated without visible outgassing, forcing us to imagine new mechanisms. Hydrogen ice too pure to detect, nitrogen sheets too thin to see, or perhaps something else entirely. Borisov taught us the opposite lesson, that some things are indeed universal. Its composition, its behaviour, its cometary nature all seemed familiar, as if to reassure us that physics works the same way around other stars. It was almost disappointingly normal, until we realised that normalcy itself was data, telling us that the processes that form comets might be common throughout the galaxy. And now, 3i Atlas teaches us the most important lesson of all, that we should expect to be surprised, that each visitor will bring its own impossibility, that the cosmos is not a machine operating by fixed rules but a garden of infinite variety, where each flower follows its own pattern of growth. The philosophical implications ripple outward endlessly. If objects from 3 different star systems behave in 3 radically different ways, what does that say about the nature of physical law itself? Are we discovering that what we call laws are more like tendencies, that universal constants might have local variations, that the cosmos is less like a clockwork and more like a jazz improvisation, following themes but always capable of surprise? These are not just abstract questions for philosophers. They have profound implications for our future as a spacefaring species. If we ever travel to other star systems, will our technology work the same way? Will our physics hold? Will we encounter phenomena that our Earth-trained minds simply cannot comprehend? 3i Atlas suggests the answer might be yes to all of these questions. And that's thrilling, rather than terrifying. It means the universe will never be boring, will never be fully mapped, will never stop teaching us. Every star system might be a new classroom, every planet a new laboratory, every interstellar object a new professor arriving to challenge what we thought we knew. The radio emissions from 3i Atlas carry a particular poetry. Here is an object singing in wavelengths we can barely detect, a song composed over millions of years of travel through the void. Not an intentional message, we have no evidence of that, but a message nonetheless. A message that says, I am different, I am other, I am proof that your local experience is not universal truth. And we're listening. With radio telescopes the size of valleys, with optical instruments that can pass individual photons, with spacecraft that can taste the chemical breath of visiting comets. We're listening with everything we have, trying to decode not a language but a physics, not words but wavelengths, not meaning but mechanism. The December 19th closest approach represents something unprecedented. Never before have we known in advance that an interstellar object would pass at a specific time, allowing us to prepare every instrument, to coordinate global observations, to focus the entire planet's astronomical capability on a single target. This is humanity at its collaborative best, setting aside nations and rivalries to stare together at a mystery. What will we see? Perhaps the acceleration will intensify, suggesting even stranger physics at work. Perhaps new spectroscopic lines will appear, revealing chemistry from another star's forge. Perhaps the shape will shift again, showing us transformation in real time. Perhaps something will happen that we lack the vocabulary to describe. The young scientists studying 3I Atlas today will spend entire careers unravelling its mysteries. Graduate students choosing their dissertations right now might still be publishing papers about this object in 2070. The data we collect on December 19th might not reveal its full significance until artificial intelligence systems we haven't invented yet can perceive patterns we cannot see. This is the long game of cosmic understanding. We plant questions today that our grandchildren will harvest as insights. We gather data whose importance we cannot gauge. We build instruments to see things we don't yet know exist. This is faith. Not religious faith, but faith in the future, faith in human curiosity, faith that understanding is worth pursuing even when it takes generations. 3 Atlas is already inspiring the next generation of instruments. Proposals are being written for telescopes specifically designed to catch interstellar visitors earlier, track them longer, study them deeper. Imagine a network of space-based sentinels at the edge of our solar system, waiting to spot the next messenger while it's still years away from perihelion. Imagine spacecraft ready to launch on intercept missions, to fly alongside these visitors, to taste their chemistry directly. But alone is a word that needs examining here. We have no evidence that 3I Atlas or any interstellar object is artificial. The scientifics, consensus remains that these are natural objects formed by natural processes, arriving by natural dynamics. But their very existence proves something almost as profound. We are not isolated. The galaxy is interconnected. Stars share their children. Systems exchange material. What forms around one sun can visit another. We are part of a vast network of stellar systems, all contributing to a galactic ecosystem we're only beginning to perceive. Every interstellar object is proof that the galaxy is not a collection of isolated islands, but an archipelago with currents flowing between. The mass loss phenomenon presents a particular puzzle. If 3I Atlas lost a sixth of its mass in days while maintaining structural integrity, it suggests states of matter we haven't catalogued. Perhaps there are ways for materials to be simultaneously rigid and volatile, structured and flowing, solid and sublimating. Perhaps millions of years of cosmic ray bombardment creates metamaterials with properties we can't replicate. These aren't just academic curiosities. Understanding extreme material behaviors could revolutionize technology. Imagine building materials that could reconfigure without breaking, that could shed mass while maintaining structure, that could survive extremes we thought impossible. 3I Atlas might be showing us engineering principles that could transform space exploration. The scientific papers being written about 3I Atlas are exercises in intellectual humility. Phrases like challenges our understanding and requires further investigation and cannot be explained by current models appear with unusual frequency. These are scientists admitting in their careful way that they are baffled. And that admission is not weakness but strength. The strength to say, I don't know, and mean it as a beginning, not an ending. Children are drawing pictures of 3I Atlas in classrooms around the world. They're imagining where it came from, what star was its sun, whether planets like Earth watched it form and launch into the void. These children will grow up knowing that interstellar visitors are real, that mystery objects pass through our solar system, that the universe is actively teaching us. What kind of scientists, artists, dreamers will they become? As we approach December 19th, we should consider what we're really watching for. Yes, we want data. Yes, we want to understand the physics. Yes, we want to solve the mystery. But deeper than all of that, we're watching for a sign. Not a sign of intelligence or intention, but a sign that the universe is still capable of surprising us, that mystery endures, that wonder has a future. The instruments are more than telescopes and spectrographs. They're extensions of human curiosity, technological manifestations of our need to know. Every photon they collect is gathered not by machines, but by the collective desire of our species to understand our context, to map our ignorance, to transform mystery into knowledge. But wisdom includes knowing what cannot be known. 3I Atlas might leave our solar system with its secrets intact. We might never fully understand what happened during its solar passage, and accepting that, being at peace with partial knowledge, might be the deepest wisdom it can teach us. We are finite beings in an infinite cosmos. Our instruments have limits, our minds have limits, our time has limits. 3 Atlas reminds us of these boundaries not to discourage us, but to make our efforts more precious. Every bit of understanding we achieve is wrestled from an infinity of mystery, and yet we keep trying. This is perhaps the most beautiful thing about humanity's response to 3I Atlas. We know we might fail to understand it. We know our models are inadequate. We know our time is limited, and still we point every telescope we have. We run every simulation we can imagine. We stretch our minds to their limits, trying to grasp what happened. This is love. Not romantic love, but something deeper, cosmic love, the love of a conscious species for the universe that birthed it. We study 3 Atlas not because understanding it will bring us profit or power, but because we cannot help ourselves. We are the universe trying to understand itself, and every mystery is a mirror. The shape-shifting of 3I Atlas is a metaphor for science itself. Just as the comet transformed under solar heat, our theories transform under the heat of new data. What seemed solid becomes fluid. What appeared permanent proves temporary. What we thought we understood reveals new depths. This is not a bug in science, but its essential feature. We are living through a transformation. The discovery of interstellar objects is changing astronomy, yes, but it's also changing us. We are becoming more cosmic in our perspective, more comfortable with mystery, more aware of our provincial limitations. We're growing into the species we need to be. 3I Atlas is teaching us patience. Real understanding takes time. The full significance of this object might not be clear for decades. The patterns connecting Oumuamua, Borisov, and 3I Atlas might only emerge after we've observed dozens more interstellar visitors. We are at the beginning of a journey that our species will be on for centuries, and that's exhilarating. Imagine the accumulated knowledge after 100 interstellar objects have been studied. Imagine the patterns we'll perceive, the physics we'll discover, the assumptions we'll abandon. Imagine textbooks written in 2125 looking back at our current confusion with the kindness historians show to early astronomers. We are those early astronomers now. Future generations will smile at our confusion, our limited models, our provincial assumptions. And that's as it should be. We are laying the groundwork for their greater understanding, asking the questions they will answer, building the instruments they will improve. 3I Atlas connects us to the future. Every observation we make becomes part of a data set that will outlive us. Every hypothesis we propose becomes a stepping stone for future scientists. Every question we ask echoes forward through time, waiting for someone not yet born to answer. This is the true significance of December 19th. Not that we'll solve the mystery, we probably won't, but that we'll gather data that might someday combine with future observations to reveal patterns we cannot currently perceive. We are taking one frame of a movie that will play out over centuries. The countdown continues. Each day brings us closer to that moment of closest approach, that opportunity to see 3I Atlas with maximum clarity before it fades forever. The entire planet is watching, waiting, wondering what we'll learn. But we've already learned the most important lesson. We've learned that the universe is still teaching, that mystery is not conquered, that wonder has a future, that every answer breeds new questions, that the cosmos is vast enough to surprise us forever, and we'll keep watching the sky. Because if 3 interstellar visitors have already rewritten the rules, what will the 4th teach us? What assumptions will the 5th shatter? What new physics will the 6th reveal? We don't know. We can't know. And that beautiful ignorance, that productive unknowing, that fertile mystery, that's the gift 3I Atlas leaves us. Not answers, but better questions. Not certainty, but wonder. Not the end of mystery, but proof that mystery is eternal. In a cosmos of infinite surprise, we are eternal students. And 3 Atlas just reminded us that class is always in session. The universe is the teacher, mystery is the curriculum, and wonder is the only grade that matters. This is what it means to be human in the cosmos, to stand on one small world, to build instruments from metal and glass, to point them at mysteries we may never solve, and to find joy in the attempt, to know we are small and temporary, yet to reach for the eternal and infinite, to accept mystery not as defeat, but as invitation. 3 Atlas will soon disappear into the darkness between stars, but its message will remain, encoded in our data, embedded in our questions, evolved into our future understanding. It came from the void, delivered its impossible lesson, and returned to the darkness. But the darkness is no longer empty, it's full of possibility. The next messenger is already on its way. Somewhere in the vast darkness, another object is falling toward our sun. It might already be inside Neptune's orbit, too faint for our current instruments to detect. When we find it, and we will find it, what impossible thing will it show us? The story of 3I Atlas is not ending. It's transforming, like the object itself, into something new. From observation to understanding, from data to wisdom, from one mystery to the infinite mysteries that await. This is not a conclusion, but a commencement. And as December 19th approaches, we stand together as a species united by wonder. Whatever we discover, whatever we learn or fail to learn, we will face it together, with our instruments pointed skyward and our minds open to possibility. This is the ultimate message of 3 Atlas. Not that we are alone or not alone. Not that physics is broken or confirmed. Not that we understand or don't understand. But that we are capable of wonder. That mystery is not the enemy, but the teacher. That the universe is vast enough to surprise us forever. The cosmos and consciousness have found each other. In us, the universe has evolved eyes to see itself, minds to question itself, hearts to love itself. And through objects like 3I Atlas, it reminds itself that there is always more to see, more to question, more to love. December 19th is no longer just a date. It's a symbol of our eternal appointment with mystery, a reminder that we live in a cosmos that can still teach us, a promise that wonder has a future. This is our cosmic calling, to witness, to wonder, to reach for understanding even when it exceeds our grasp, to be the universe's way of knowing itself, even partially, even imperfectly, even temporarily. Atlas has shown us who we are. We are the species that looks at impossible things and asks why. We are the ones who build instruments to see invisible light, who write equations to describe impossible motion, who refuse to accept mystery as final. And the experiment continues. With every interstellar visitor, with every impossible observation, with every shattered assumption, the experiment grows more interesting. We are not just observing the cosmos, we are participating in its evolution. This is the dance, the eternal dance between known and unknown, between question and answer, between wonder and understanding. 3I Atlas is our current partner in this dance, leading us through steps we didn't know existed. And when it finally fades from view, we won't mourn its departure. We'll celebrate its visit. We'll celebrate the mystery it brought us, the questions it raised, the assumptions it shattered, the wonder it renewed. The universe has sent us a message in the form of impossible behavior. The message is simple. There is more. More to discover, more to understand, more to wonder at, always, eternally, infinitely more. And we, small conscious specks on a pale blue dot, receive this message with gratitude. Thank you, 3I Atlas, for reminding us that mystery endures. Thank you for showing us that our knowledge is an island in an infinite ocean. Thank you for proving that the universe can still surprise us. Thank you for being impossible.